For a long time, the maps of our planet felt complete. Every ocean measured, every continent accounted for. And yet, there was a problem. Why did 19th century scientists insist that a vast landmass once existed in the Indian Ocean? What makes this strange is that animals in India and Madagascar share evolutionary links that shouldn't be possible. No land bridges, no clear migration paths, only absence. And if Lemuria never existed, why did so many serious scientists believe it had to? Before answering all these questions, grab a coffee or your favorite snack and welcome to another episode of Deep Records.
For centuries, the world made sense as a collection of fixed pieces. Continents were permanent, oceans were final. Nothing large ever truly disappeared. At least, that was the assumption. In the mid-19th century, science was facing a quiet problem. Not a mythological one, a biological one. Naturalists were mapping the distribution of animals across the globe, cataloging where species lived and where they did not. And what they began to notice was deeply uncomfortable. Lemurs. They lived in Madagascar, they lived in India, and almost nowhere else. What makes this strange is not their existence, but the gap between them. Thousands of kilometers of open ocean, no natural land bridges, no known migration routes, and no evolutionary explanation that fits the rules of the time. In 1864, British zoologist Philip Sclater published a paper in the Quarterly Journal of Science that would introduce a radical idea. Not a legend, not fantasy, but necessity. Sclater argued that the only logical explanation was the existence of a vast landmass, now gone, that once connected Madagascar to the Indian subcontinent, a continent that allowed lemurs and other species to spread freely before vanishing beneath the sea. He named it Lemuria. Not after a myth, not after folklore, but after lemurs. At the time, this was the only explanation that made sense, because in the 19th century, continental drift did not exist. The idea that continents could move, split, or collide had not yet entered mainstream science. Land was assumed to be static, immovable, permanent. So when species appeared on opposite sides of an ocean, scientists were forced to look for something else: lost land. And Lemuria was not alone. Similar hypothetical continents were proposed elsewhere, ideas like land bridges across the Atlantic or submerged connections between distant regions. These were not fringe concepts. They were discussed seriously, debated in journals, and taught as working theories. Lemuria fit neatly into this framework. It explained not just lemurs, but patterns in reptiles, plants, and other animals, whose distribution seemed impossible to reconcile with fixed continents. For zoologists, it solved a problem that otherwise had no solution. But there's a problem. Lemuria was never observed. No maps recorded it. No ships reported ruins rising from the sea. Its existence was inferred, built entirely from absence, from what should have been there. Still, for decades, Lemuria remained a respectable scientific hypothesis. It appeared in academic discussions. It was referenced by naturalists trying to make sense of life's strange geography. Not because it was extraordinary, but because it was necessary. If continents never moved, then where did the land go? That question lingered, quietly, waiting. And for a time, Lemuria filled the silence, an invisible continent, accepted not because it was proven, but because nothing else could explain the evidence staring back at 19th century science. What came next would change everything, but not yet. Over vast stretches of time, Lemuria was not imagined as a small island lost to the sea. It was envisioned as something far larger, a continent. According to the scientists who first proposed it, Lemuria stretched across the heart of the Indian Ocean. Not randomly, but deliberately, like a missing bridge between worlds. On one side, Eastern Africa, on another, Madagascar. Farther east, India, and just beyond it, Sri Lanka. At the time, this was the only explanation that made sense. These lands were separated by thousands of kilometers of open ocean, and yet their geology whispered of familiarity. Their ecosystems echoed one another, and their fossil records told a story that refused to stay contained within modern coastlines. What makes this strange is not where Lemuria was placed, but how carefully it was drawn. Early maps showed a vast landmass submerged beneath what is now deep ocean water. A continent whose highest peaks might once have stood above the waves, and whose lower regions, over time, were slowly claimed by the sea. Not through a single cataclysm, but through drowning. As the decades passed, the ocean floor itself began to speak. Bathymetric surveys of the Indian Ocean revealed features that did not behave like ordinary sea floor. Broad plateaus, unusual rises, regions where the crust was thicker than expected. Submerged ridges stretched like scars across the abyss. Silent plateaus sat thousands of meters below the surface, flat and extensive, as if once shaped by forces other than deep-sea volcanism. One of these regions became impossible to ignore, the Mascarene Plateau. Hidden beneath the waters east of Madagascar, the plateau spans hundreds of thousands of square kilometers. It is not jagged like a typical oceanic crust. It is wide, stable, and unsettlingly continental in character. For a long time, this was treated as coincidence. But there's a problem. The oceanic crust is young. It is constantly recycled. Continental crust is ancient. It survives. And when scientists began to analyze samples from the Mascarene region, they found something that should not have been there: zircons. Tiny mineral grains resistant to time, pressure, and heat. Some of them dated back more than 2 billion years. At the time, this was not just unexpected, it was impossible. Zircons of that age do not form in oceanic crust. They belong to continents. In 2013 and again in 2017, teams of geologists publishing in Nature Geoscience proposed something radical: that beneath the Indian Ocean lay fragments of a lost continent. They named it Mauritia. Not a myth, not a legend, but a microcontinent, a sliver of continental crust torn apart during the breakup of ancient landmasses. According to these studies, Mauritia once sat between Madagascar and India before tectonic forces stretched it thin, before volcanic eruptions buried it under layers of basalt, before the ocean swallowed it whole. To some, this sounded familiar, too familiar, because for over a century, Lemuria had been described in almost the same place, submerged, fragmented, reduced to remnants scattered across the seafloor. Indian Ocean bathymetry surveys continued to reveal anomalies, elevated regions where the crust refused to behave like normal ocean floor, areas where gravity measurements hinted at buried continental material. None of this proved Lemuria, but none of it erased the questions either. If fragments of continental crust exist beneath the Indian Ocean, how many are there, and what once connected them? For now, geology offers pieces, not pictures, data, not narratives, and somewhere between belief and measurement, Lemuria remains suspended, not on maps, but beneath the waves.
Through most of recorded history, Lemuria existed because it had to. It wasn't born from fantasy. It wasn't mythology slipping into science. It was a solution. One that made sense in a world where continents were believed to be permanent. But then, in 1912, something changed. A German meteorologist named Alfred Wegener proposed an idea that sounded almost absurd at the time.
He suggested that continents were not fixed, that they moved, slowly, invisibly, across the surface of the planet. At the time, this was the only explanation that didn't require land to simply vanish. Wegener noticed something others had ignored. The shapes of continents fit together, almost like fragments of a broken shell. Fossils of the same plants and animals appeared on lands now separated by vast oceans. Rock formations matched across continents that should never have touched. His theory was called continental drift, and for decades it was ridiculed. What makes this strange is that Wegener couldn't explain how continents moved. He had evidence of motion, but no mechanism, no engine beneath the surface. So the scientific community waited. And while they waited, Lemuria remained, quietly, awkwardly, on the margins of credibility. Then, in the mid-20th century, the ocean floor began to speak. New technologies revealed something no one had seen before. Mid-ocean ridges, symmetrical magnetic patterns frozen into basalt, entire mountain chains hidden beneath the sea. The theory of plate tectonics emerged. By the 1950s and 60s, it offered what Wegener could not: a moving crust, floating plates, a planet constantly reshaping itself from within. Suddenly, animal distributions made sense without vanishing continents. India had once been attached to Madagascar. Africa, Antarctica, Australia, once connected, then torn apart over millions of years. Lemuria was no longer needed, and so it was officially dismissed, quietly removed from textbooks, sidelined in academic discussions, reclassified as a historical footnote, a wrong idea from a less informed age. But there's a problem. Plate tectonics explained movement, it explained separation, but it did not erase every question Lemuria had been created to answer. Because while continents drift, they do not simply sink. Continental crust behaves differently from oceanic crust. It is lighter, thicker, more resistant to subduction, which raises an uncomfortable detail. If Lemuria never existed, why do fragments of continental material appear beneath the Indian Ocean? Microcontinents, ancient zircons, submerged plateaus with compositions that don't belong to the deep ocean floor. None of this resurrects Lemuria as it was imagined in the 19th century, but it complicates its burial. What happened instead was not a clean correction, but a replacement. A better theory arrived, a broader framework absorbed the mystery, and the older idea faded, not because it was completely disproven, but because it was no longer necessary. Science moved on. Yet Lemuria never truly disappeared. It lingered in the gaps, in unresolved data, in the quiet acknowledgement that even correct theories have blind spots. And perhaps that's the most unsettling part. Not that Lemuria was wrong, but for a time it was right enough. And when science replaced it, it didn't close the case. It simply changed the questions. If it existed, Lemuria was not a single shape frozen in time. It was a landscape in motion. Based on what we know about ancient continents, it would not have been flat or uniform. It would have risen and fallen, broken by highlands, cut through by long river systems carrying sediment toward shallow inland seas. For a long time, reconstructions imagined Lemuria as a simple land bridge, a narrow connection between distant shores. But what makes this strange is that such bridges rarely support the biological complexity Lemuria was meant to explain. So imagine something larger, a broad landmass stretching across the western Indian Ocean, elevated plateaus in its interior, mountain chains formed by slow tectonic compression long before separation began. From these heights, rivers flow outward, wide, slow, and warm, feeding dense lowland ecosystems. The climate matters here. Based on paleoclimate reconstructions, the Indian Ocean region during this period was warmer than today. Sea levels fluctuated. Rainfall was seasonal but intense. If Lemuria existed within this system, it would have been humid, not endlessly wet, but reliably fertile. Tropical forests dominate the lowlands, not impenetrable jungles, but layered ecosystems. Tall canopy trees, thick undergrowth, open clearings shaped by natural cycles of flood and drought. Closer to the coasts, mangroves and wetlands form natural buffers. Shallow continental shelves extend far into the sea, creating lagoons and estuaries rich with life. This is not a paradise, it's productive, but demanding. Storms move in from the ocean. Volcanic activity is never far away. Earthquakes occasionally reshape the land without warning. But there's a problem. Land like this does not vanish easily, which means Lemuria, if it existed, likely disappeared in stages. Based on Gondwana breakup models, separation would have been slow, measured not in years but in millions of them. First, fractures, then rifting, then subsidence. Coastal regions sink first. Lowlands flood. River mouths turn into bays. Forests retreat inland as saltwater advances. The interior survives longer. Highlands become islands. Plateaus fragment into isolated landmasses scattered across a widening ocean. This slow collapse changes everything about life on the continent. Species become trapped. Populations shrink. Evolution accelerates under pressure. Which is why Lemuria is best imagined not as a lost Eden, but as a biologically rich landmass under constant stress. Isolation creates diversity. Fragmentation creates specialization. Animals adapt to shrinking habitats. Plants evolve to survive unstable soil and shifting coastlines. Some lineages thrive, others disappear completely. And all of this happens long before the final submergence. What remains, eventually, is no single moment of destruction, no dramatic sinking, just the gradual erasure of continuity. Based on what we know, the final form of Lemuria would have looked nothing like its beginning. A scattering of islands, ridges barely breaking the surface, continental fragments surrounded by deepening ocean basins. From above, it would appear broken, from below, unfinished. And this matters because it reframes the mystery. If Lemuria existed, it was not lost all at once. It was unmade, piece by piece, coastline by coastline, until what remained no longer resembled a continent at all. Which makes the question more difficult. Not how Lemuria disappeared, but how long life had to adapt before it did.
For a long time, the people of Lemuria have been imagined before they were understood. That's the first problem. There are no cities beneath the Indian Ocean, no skeletons pulled from the seabed, no tools, no bones, no unmistakable human trace. Everything about Lemuria's inhabitants exists in theory, and speculation begins where evidence ends. Based on what we know, if Lemuria existed during the window proposed by early scientists, it would have overlapped with a critical period in human evolution, a time when multiple hominin species shared the planet, some thriving, some vanished without explanation. Early human migration studies show movement out of Africa far earlier than once believed. Not a single wave, but many. Some were successful, some are forgotten. If Lemuria existed as a stable landmass during this time, it could have served as a corridor, or a refuge, or an isolated evolutionary pocket. But there's a problem. Isolation changes populations.
Cut off by rising seas and shifting land, any group living on Lemuria would have evolved separately. Not dramatically, not overnight, but subtly. Different proportions, different adaptations, different survival strategies shaped by a tropical, unstable environment. Paleoanthropology in South Asia already hints at this complexity. Fragmentary fossils, incomplete records, gaps measured in tens of thousands of years. What makes this strange is not that we lack answers, it's that we expect there to be only one. If Lemuria hosted early hominins, they were not a single people. They would have been small groups, scattered, vulnerable, hunter-gatherers adapted to forests, wetlands, and coastal zones, dependent on rivers, seasonal food sources, shifting shorelines. Their lives would have been defined by movement, following animals, avoiding floods, retreating inland as the sea advanced. This is where later interpretations begin to drift. Centuries after Lemuria was first proposed, myths grew around it. Stories of giants, of beings with impossible intelligence, of civilizations far beyond their time. But this is not evidence. They are reinterpretations, cultural echoes layered onto an absence of data. Not gods, not monsters, but unknown. What survives from real anthropology offers no support for exaggerated stature or advanced technology. No indication of non-human intelligence. No sign of a lost super-civilization erased overnight. At the time, this was the only explanation for something else entirely. When people tried to make sense of missing links in evolution, they filled the gaps with imagination, and Lemuria became a canvas. But speculation, when left unchecked, grows louder than evidence, so it's important to pull back. If Lemuria had people, they were likely ordinary by evolutionary standards, skilled, adaptable, but constrained by their environment. Their tools would have been simple, organic, stone and wood that rarely survive deep time, especially underwater. Their social structures would have been small, kin-based, flexible. No empires, no centralized states, just survival. And when the land began to break apart, survival became harder. Groups would have been separated, populations isolated on shrinking islands, some adapting, others disappear entirely. No final migration, no recorded exodus, just silence. Which leaves us with an uncomfortable truth. The absence of remains does not mean the absence of people. It means the conditions were perfect for erasure. Oceanic submersion destroys evidence, organic material decays, stone scatters, and over enough time, even memory fades. So the people of Lemuria remain exactly where science leaves them, between possibility and proof. Not legends carved in stone, not fantasies disguised as history, but human lives that may have existed and left no trace strong enough to survive the sea.
Long before anyone noticed, the animals were the reason Lemuria was imagined in the first place. Before maps were redrawn and theories replaced, it was biology that raised the alarm. Madagascar, an island separated from Africa by hundreds of kilometers of open ocean. An island that should not share deep evolutionary ties with distant lands, but it does. What makes this strange is not what lives there today, but what once did. Subfossil records reveal a world that no longer exists. Giant lemurs once dominated Madagascar's forests. Some stood as tall as a human. Others moved with a slow, deliberate weight, more like ground sloths than the agile creatures we know now. They were not rare. They were not isolated curiosities. They were part of a stable ecosystem, and then they vanished. But there's a problem. Lemurs do not cross oceans easily. They are not strong swimmers. They do not migrate over vast stretches of open water. At the time, this was the only explanation.
a lost land connecting Madagascar to larger continents. Today, plate tectonics explains part of the story, but not all of it, because lemurs are only the beginning. Madagascar once hosted reptiles that defy simple classification, mammals found nowhere else on Earth, lineages that appear abruptly and end just as suddenly. Some species show no clear migration route, no stepping stone islands, no gradual dispersal pattern. Evolutionary biology journals describe these as dead ends, branches of life that flourished briefly, then stopped. Isolation does that. When populations are cut off long enough, evolution accelerates in strange directions. Bodies grow larger, limbs change function, behaviors shift. What emerges looks familiar, but not quite right. A lemur too large, a reptile too specialized, a mammal adapted to a world that no longer exists. This is where Lemuria lingers, not as a place, but as a pattern. Similar anomalies appear across the Indian Ocean region. Fossil distributions that feel incomplete, species that imply connection, then deny it. Not proof, but pressure. Pressure on the idea that islands were always islands. What makes this unsettling is the timing. Many of these creatures vanish long before recorded history, long before humans arrive in large numbers, long before climate shifts explain everything. Their extinction aligns not with catastrophe, but with change. Land shrinking, habitats fragmenting, coasts retreating inward. And yet, the animals don't adapt fast enough. Some evolve into forms that only make sense in isolation. Others become too specialized to survive when conditions shift again. The fossil record shows this clearly. A rise, a peak, a sudden absence, no gradual fade. Which leaves us with a quiet contradiction. If Lemuria never existed, then evolution in this region followed an unusually narrow path, one that produced extremes and erased them just as cleanly. But if land once connected these ecosystems, even briefly, then these creatures stop looking impossible. They become remnants, survivors of a geography that no longer exists. Not monsters, not myths, but biological signatures of a world that was never meant to last. And they remain, silent, incomplete, and deeply inconvenient, because they don't demand belief. They demand an explanation.
For ages, the end of Lemuria was imagined as a moment. A sudden collapse, a continent swallowed whole, a single catastrophe erased from memory. But the evidence suggests something quieter. Based on Indian Ocean tectonic models, large landmasses do not disappear overnight. They fracture, they thin, they sink slowly, unevenly, one coastline at a time. There are two ideas that continue to surface. The first is gradual breakup, rifting driven by plate movement, land stretching until it weakens. Highlands survive longer as lowlands flood and retreat. In this version, Lemuria does not fall, it dissolves. The second idea is more abrupt, catastrophic subsidence triggered by volcanic activity and unstable crust, rapid sinking over geologically short periods, still vast by human standards, but sudden in the life of ecosystems. Both scenarios agree on one thing: water rises. Sea level studies show repeated surges during the periods Lemuria was proposed to exist. Ice melts, oceans expand, shorelines redraw themselves again and again. For low-lying regions, this is enough. Forests drown, rivers become bays, freshwater turns brackish, habitats fracture into isolated pockets. But there's a problem. Submergence does not leave ruins, it leaves an absence. No collapsed cities, no broken monuments, no clear moment of loss, just sediment, pressure, time. Volcanic activity adds another layer of erasure. Basalt flows reshape the seafloor. Ash blankets ecosystems already under stress. Chemical changes alter marine life and accelerate decay. Whatever existed on the surface is broken down long before it reaches the depths. And then, memory begins to fail. Not all at once, but slowly. Maps change, coastlines shift,
islands become legends. By the time written history begins, Lemuria is already gone. So why does it survive at all? What makes this strange is that Lemuria persists where evidence does not. It returns in speculation, in fringe science, in cultural imagination, not because it was proven, but because it answered a question no one else could, at least for a time. When science rejected Lemuria, it did not replace the sense of loss that came with it. It replaced the mechanism, and mechanisms don't tell stories. Lemuria became a symbol of missing time, of gaps in the record, of how much of Earth's history unfolded without witnesses. It survives because forgetting feels incomplete, because entire ecosystems vanished without ceremony, because human memory struggles with slow disasters. We understand explosions, we understand floods, but disappearance through patience, through millennia of incremental change, feels unsettling. Nothing to mourn, nothing to rebuild, just absence. And that may be the most honest ending Lemuria ever had. Not destroyed, not disproven beyond doubt, simply submerged beneath layers of better explanations and deeper oceans. Which leaves one final question. If entire continents can fade without leaving a trace, how much of our planet's story has already done the same?